So how do we implement neural networks in TensorFlow? On the highest level, we have the tf.keras.model. We can use this class to very easily instantiate model objects. For that, we make use of the functional API. And so all we need for that is to specify the structure of our input. So here we have tf.keras.input with a shape of 3. So that could be a one-dimensional tensor with 3 elements, for example. And then we specify what we do to this input. So here we apply dense layers. So here a dense layer of 8 neurons to our input. To that a dense layer of 4 neurons. And then finally a dense layer of 2 neurons. And we pass then the structure of the inputs. So here and what we do to this input to the constructor of the tf.keras.model. And then we get a model back. We can then compile this model, fit it to some data, and then get some predictions for some unseen data. A quick note on the dense layers here. Dense just means that it is connected to every neuron in the previous layer. Now, while this functional API is very simple and also the best practice in many cases, we want to, in this course, give you a more fundamental understanding of neural networks, which cannot be really captured in these few lines of code here. And so instead, we will subclass the model class and write our own model classes. And that is what we can see here. So we have here our custom class myModel, and it inherits from the tf.keras.model. And the important things that our model class needs are first the initialization, where we define what kind of layers our network is made up of. So here, for example, we have first a dense layer with 4 neurons, and a reload activation, and then here we have another dense layer with 2 neurons and a softmax activation. And once we have defined how we want to initialize our network, we then define how the forward pass should take place. And this is done in the call method. So our inputs will first go through the dense layer 1. So our dense layer is applied to the inputs. We assign it to our x, and then the x goes into the second dense layer. So here. And then finally, we return the model output. Once we have defined our class, we can then instantiate an object with it. So here we have our model as an instance of our model class, and we can think of some inputs. So for example, we have x here as a constant tensor with the values 1, 2.5, 3.8. And when we put it into our model, we will get 2 values back, since our last output layer is a layer of 2 units. And the outputs here will also add up to 1 since we applied the softmax activation. Okay, so that gives us already a better structural understanding. But we can go even further by not using these predefined layers here, such as the dense layer. And instead, we will again subclass from the class that also these layers here inherit from. And this class is called the tf.keras.layers.layer. That is quite a long name, and so are the layers inheriting from this class. But what we can do is to just import from the tensorflow.keras.layers the dense layer directly. Then we only have to write dense and not tf.keras.layers.dense. So now back to our custom layer class. We again have the initialization here, and there we define how many units our layer should have, so how many neurons. And then we can also define what kind of activation function we want to apply to our drive. So here we set it to a softmax. And of course we can name these attributes here as we like. So we could, for example, name them self.units_num, so the number of units. That would work. Or activation function, for example, or whatever we want. But let's stick to activation and units. And then again, go straight to the call function. So what happens when our layer gets some input. And here we can see the structure as we've learned it. So the inputs are multiplied with our weight matrix, and then we add a bias. And that gives us the drive, and to the drive we apply the activation function, and that we return as our output. Now to the weights and the bias. These are created in the build function. And we can create a weight matrix simply by calling self.addWeight. So addWeight is a function already provided by the tf.keras.layers.layer class. So you can just use it. And its arguments are a shape. So first the input and then the output. We can also determine how we want to initialize these weights. So here we use a normal distribution. And then we can also set the layer to trainable. We could also set them to untrainable, so if we replace that with false, but for now that will not be of use for us. And then the same goes for our bias here. We will again treat that as a weight, and since every neuron gets a bias, the shape will be equal to the number of units that we have. So now you may ask, why do we need this build function here? Couldn't we just place it all in the initialization here? And we could do that, but if we go again up here to our subclass model, we saw that we could just put in some tensor here, and the shape did not matter. So if we add a 4 here and run that, it works just as well. And this works because our tf.keras.model also provides a build function, which it inherits from the layer class. And what the build function now does is that it builds the network structure based on the input shape. So only when our model, or here our layer, is called for the first time, then the structure is set up. And so we can match then our matrices to the corresponding input. And so we see here the input shape is an argument to the creation of our weight matrix. Okay, so once we have defined our custom layer class, we can then again instantiate that layer. So here we choose 4 units, and then we can call that layer again with some tensor, so our x here, and we get an output. So that's that part here, and we get 4 values since we chose 4 units for our layer. Okay, so we have now model, we have layer, but we could go even deeper to the tf.module. From this tf.module, the layer inherits. So this is really the base for the higher level structures such as layer and model. And what this tf module is simply a container for tf variables or other tf modules and functions that we apply then to some user input and also the variables and modules. So this is very general. So we have here, for example, when we build our own module, subclassing the module here, we have then, for example, a variable that we assign the tf.variable, which has the initial value of 5, then a non-trainable variable here, and then the function that we base on some input will be to multiply the a variable with our x and then add the non-trainable variable. And so what we see here could also be done by just inheriting from object, but what we can now do is we can access the attribute variables, and if we run that, then we get access to the variables of that module here. So here is the train me, that's that one, and then we also have the do not train me, that is that one. And this functionality can then be used to train this module. So we could update then these variables, at least the trainable ones. But for this course, you don't have to be concerned much with this tf.module. Our main focus will be on subclassing the layer and also the model class. So when your task is now to build a model, you can start by subclassing the tf.keras.layers.layer and create your own layer. And with that, you can create your own model class by subclassing the tf.keras.model. And in there, you can then use your custom layers. Now, what you can also do is just stick to layers, because you could, for example, have a layer that contains again layers. So not just one weight matrix and a bias, but instead again maybe 2 or 3 dense layers. And we can nest that as deep as we want. And so the reason we actually subclass then from this tf.keras.model and create our custom model classes is that it allows us to very easily train, evaluate, load, and save. But because in this course we want to do the training, evaluation, and so on, not the easy way, in terms of just writing a few lines of code, you could in theory just stick to subclassing the layer class. But doing it that way gives it a bit more structure and will be useful for later on. Okay, so again, for the homework, you are not allowed to use the functional API. And for now, you should also not use the predefined layers. Eventually that will be allowed. So for you, subclass layer or subclass model.